Hello and welcome to this fourth video, which focuses on using the engineering resources. So in this video, we will talk about the format of the drawings, some specific details that are contained within the drawings, and we'll go through the additional files that are provided. So the drawings for the design are in 4 different types. There are assembly drawings, fabrication drawings, machining drawings, and part drawings. And I'll just in turn explain a little bit about each of these different types. So assembly drawings are used to show how completed parts are assembled together, and they will also include components, fasteners, and fixings that are bought and not made. So these drawings have the following file structure. So it's TUR for Turgo, P225 for 225 PCD, and then an A for assembly. They may also contain additional instructions for actions that need to be taken during the assembly process. So let's look at an example. Here we have the drawing of the inlet assembly. And what you'll notice in the top left is a list of parts. In the bottom right is the title block for the drawing, which has some important details. So within the assembly drawing, we have the parts list in the top left. So that part list mentions all of the parts, whether they are ones that have been made or ones that have been bought, like these fasteners here. And the numbers that are listed here are then used to identify those parts on the drawing. We also have detailed views which provide particular information. So here we can see it's identified that there is a bolt and washer indicated by the 8 and the 11th, that there are 8 of them, and there's an additional instruction which is to apply a thread locker or similar. So fabrication and machining drawings are another type. Fabrication drawings show how parts are positioned relative to each other before welding, and then machining drawings usually take the same collection of components shown in a fabrication drawing and then indicate how they will be machined to reach their final form. So it's good practice to look at a machining drawing to get an understanding of what the final form of a component is, whilst the fabrication drawing will indicate all of the other parts that are needed in order to make the complete component. And in their file structure, they use the letter F to indicate that it's a fabrication, and then at the end it will state whether it's a fabrication or a machining drawing. So let's look at an example. Here we have the deflector, and this is the fabrication drawing. In the top right, we have a parts list, and then the numbers are used to indicate where those parts are in the assembly. And so you'll see that there are a few dimensions to locate how the components should be aligned to one another. Now we can look at the machining drawing for the same part. And what you see is it looks much the same, but now there are a few additional details. We now have a hole that has been bored through the center with a dimension here, and 2 other holes that are added on this section with the dimensions used to define them. So the final type of drawing is part drawing, and they show machining or forming details for an individual part. They use a P to indicate part, and they're used for standalone parts or parts that are then cut and used in fabrication. So let's take a look at an example. So this is a standalone part. It's the deflector shaft cap, and so it's only this part is needed, and so the machining can take place, and then this part will be complete. So a few details from that you'll find within the drawing. In places, dimensions are used with tolerances, and what this means is that any value within the band is acceptable. So in this case, anything between 358 and 363 is an acceptable dimension. And so these are used where material is cut large for fabrication, and then later in the machining drawing, there'll be a final, more precise dimension. We also use ISO tolerances where precise dimensions are needed, and this is often when two components are joined together. So there's an example here. We have a diameter of 160 nominally, then this ISO code of F7 states that the dimension needs to be within this band, and that needs to fit to the nozzle orifice plate. So this part will have a similar precise dimension, and that will ensure that there is a good fit between these two components. This link here at Roymec, if you Google Roymec ISO limit, then you'll find some more information about those. Within the drawing, due to the experience of Nepal Yantrashala Energy, the welding was based on the experience of the company and its welding technicians. So generally in the drawings, you'll just see black triangles to indicate where welds are required. As a general rule, for fillet welds and V-notch welds, you can use S as being 3/4 times the material thickness. And so this is a fillet weld here, and this is a V-notch weld here. In the drawings, you'll find some dimensions that are provided in brackets. These are called reference dimensions, and these are used either to indicate that the same dimension is repeated multiple times, or they highlight an important dimension that has come from elsewhere. So it might be that there's a dimension, say for example, thickness of material, that's the same in a fabrication and machining drawing, and in that case, we would put the dimension in brackets. So a couple of important pieces of information about the design. A spear handle design has not currently been provided, as the one used for the Mungmaya turbine was a proprietary design from NYSE. We will be able to support participants in developing an appropriate design for the spear shaft handle. Design currently provided is for a direct drive. The shaft could be lengthened and could be used to incorporate a transmission system, and so that adaptation is possible. And throughout the design, it's suggested to use a 6mm O-ring in all the places where there are O-ring grooves. So the design resources provided are a bill of materials, PDF drawings, .dwg drawings, 3D CAD files for 3D printing, and a 3D PDF of the Mungmaya turbine that has already been made. So firstly, there's a brief video that explains how to use the bill of materials. Hello, this is a brief demo of the bill of materials. So this first page is a README, which gives an overview and explanation of what each of the different sheets are. There's an acknowledgement statement and a liability statement as well. So the first sheet is the drawing list. Along the top, we've got these different columns. So parent, part number, part/drawing number, part name, quantity, material, and file name. And so what this sheet does is allows you to identify whether a part to be made from a drawing is an individual one or one that is part of a fabrication. So these at the top, you see they have no parent part number. So taking the nozzle, for an example, it's a standalone part. And so if you look at the part drawing number TUR_P225_F_013, if you find that drawing, then that drawing will be the nozzle. But if we consider, for example, all of these parts that make up the casing, so they're all individual parts that have a parent fabrication, and associated with the casing there is a fabrication and a machining drawing. So all of these parts that are listed beneath the darker blue heading are parts that will need to be made, or material that needs to be cut to size before then they are fabricated and machined. And so you'll need to follow that structure in order to make those parts. So all of the different drawings are identified here that will correspond to your PDFs and .dwgs. If we move across to the bill of materials page, then this lists for all of the completed components how many there are, so the quantity, and where you'll find them in the assembly drawings. So as an example, now the casing is just a single component, so all of those other part drawings that made up the entire casing are not found in the bill of materials because they have all been combined together into the casing. So this can be filtered by any of these columns. And so there's the master assembly, which contains the all of the other parts, and then two other major assemblies, which are the inlet assembly and spear assembly. The final tab is bought out components, and this is just a list of mainly fasteners and fixings that are used in the design, and that can be used to easily order all of them. It should be noted that this also includes the bearing housing and roller bearings and adapter sleeves that were used in the Mung-Meyer turbine. So this is the relevant part numbers for those. So hopefully that gives you an idea of how the bill of materials works. Thank you for listening. There's a full drawing pack of PDF files, and as explained in the previous video, there will be some dimensions that need to be updated according to the design spreadsheet. So we can see here on this image on the right, where there is no dimension provided, but instead it says inlet flange _ O-ring _ ID. That dimension needs to be extracted from the design spreadsheet. And so within that design spreadsheet, it lists all of the drawings where there will be dimensions that need to be updated. .wg files are provided as we're aware that there are many potential users of Autodesk. And so within these drawings, it's possible to edit the values from the design spreadsheet rather than have the text in there. And the drawing is provided at 1:1 scale in the model space, and so it can easily be edited there. 3D files are provided that allow 3D printing of the runner blades and templates for finishing a runner blade. And these are provided in 2 file types, which should be sufficient for anyone with access to a 3D printer to be able to use. We're also providing a 3D PDF, which allows full visualization of the Longmire turbine. So the following video demo just briefly shows this 3D PDF. This is a quick demo of the 3D PDF. You can download Adobe Acrobat Reader for free, and the only other thing that you may have to do is enable 3D content. And so to do that, you go Edit, Preferences, Multimedia 3D, and make sure that this box, Enable Playing of Multimedia and 3D Content, is clicked. And then what that allows you to do is access this 3D model of the complete design, and you can move it around, zoom in and out, do section views. So there's one here, we can hide that cross section, and so basically it allows you to get a feel for what the complete design looks like. Along here down the side, there are all of the parts listed, so you should be able to identify all of the parts from there, and if you click on them, then it will highlight it within the 3D PDF. So hopefully that's a useful tool, allowing you to manipulate and get a better understanding for what the design looks like in 3D. So in summary, we've outlined the types of drawings that are included within the design resources. We talked about some specific details in the drawings, and we've also explained all the different types of file that are provided. Thank you very much for listening.